Hello, Joe Shaw here, engineer in the incubation department for APM. Another weekly update video. Mixed week this week, looking at historic information in GitLab and talking to people, and looking at a bit of research around potential time series databases or general column storage databases we might be looking at using to store all this performance data, and looking specifically at the Datadog agent and how we can set that up and use that as an agent and create our own version of the Datadog API, a simplified version that we can use in production. This first page I'm just showing you here is one of the issues I've got open that will stay open, and I'll keep adding to it. It's an historic issue project, Epic Tracker, for parts of the organization that I want to keep a tab on. A lot of this stuff is probably over a year old now. So whilst I am talking to people in the business, it's a lot of this information is too old for people to recall easily enough. They'll only remember the salient points. So it's useful for me to dig into the details. So I've managed to search and track down some epics issues that are quite pertinent to what we're doing here. An open MR there in a run book, and some more internal docs that I don't feel are for the general reading list in the handbook, but are still quite useful. There's one or two ones that are specific to research, for example, in Grafana usability and things like that. So an example of one of these issues, well, an epic was for actually dog fooding the monitoring there. And you can see a discussion starts where they're talking about it, and looking at actual dashboards that were looking to dog food into GitLab here. And this was a year ago. You can see these are all comments from 2020, early 2020, and it eventually gets closed off. But you can see the sort of discussion that's going on here. And likewise, jumping off from that, you can see things like existing issues that have been created around things like Datadog. So looking at agent metric collection here, and digging down into this, there's some interesting stuff. I don't think anything ever got fully completed here or even started, but it's all interesting information anyway. And a lot of this was focused on being able to monitor CI jobs, for example, within different environments. So if you're running your own GitLab runner for CI, how you monitor, make sure that's still performing well. And you can do all that with Prometheus right now. But if you've already got a Datadog integration, then you might want to be able to do that directly. So there's some work that was going on there. And I do believe that a Datadog integration was completed recently for the runner in one of the recent releases of GitLab. So that's great. So before I move on to talk a little bit about why we're looking at Datadog runner specifically, I'll obviously get people asking me why not jump straight to using the Open Telemetry project, which is a great community project that's brought together and is stood on a number of other projects that have folded into it. For example, I think Open Metrics was one that's been folded in. I'm not sure about Open Tracing, but working on things, looking at things like how you standardize the metric data structures, trace data structures, log data structures, because they all tend to be very similar. And then how you can create an agent, things like that on top of that. So you can see in the actual documentation here for Open Telemetry, where was I going to look? You can see the kind of reference architecture there would be very similar to something that we would look at using. You've got your own, you've got a open telemetry collector, pushing data into it. A very simple single agent architecture. The problem when looking at this is the level of maturity. So for example, if you look at the Go language instrumentation, you've got very, very low level release candidates, alpha releases, and no logging implemented there at all, for example. And at this point, we wouldn't want to give this to customers to use because it wouldn't be at a level of maturity, which would mean that they could just get going with it straight away. Whereas you look at something like Datadog that's open source and well, the agent is and the libraries are, and it's very well documented, and there is a big community around it and lots of solved issues and things like that. People will be able to get going very, very quickly with that. Whereas in this scenario, I've seen, for example, GitHub were using, started to use OpenTelemetry with Ruby, and it looks like they've had to put a lot of work in to get that going, based on a recent blog post. And a business of that size and technical capability can do that, whereas a lot of small to medium-sized businesses simply can't. So that's one of the reasons behind not jumping straight in with OpenTelemetry, but we will keep looking at it and keep an eye on it as time goes on. So just as an aside, I've also been looking at time series databases and ways we can store all this information. One of the things we want to keep in mind is trying to pick a solution that might be able to solve all areas of observability as opposed to just solving for time series data. And by time series, I usually just mean metric data where you've just got a floating point number and tags and timestamp, which are, there are a lot of databases that support that. We're also looking at log data, which can be sort of full text searchable data, and trace data, which again, whilst it's all timestamp indexed, it's a very different data structure. So we're looking to have that level of flexibility. Now, I stumbled upon QuestDB here, this blog looking at benchmarking, and there's a benchmarking suite, the time series benchmark suite, which I think was created. It's owned open source by Timescale here, which is another time series database based on top of Postgres. And this was an interesting one because you can see here the sort of throughput test that they're doing. ClickHouse comes out as a very strong contender versus other things like Influx, Timescale, which are very good time series databases, don't get me wrong. Timescale, based on Postgres, has some limitations there in terms of scalability. And also Influx, it's another open core model. It scales vertically really, really well on single nodes, but then when you're wanting to do horizontal scaling and replication, you then have to get an enterprise license for that. Whereas ClickHouse, theoretically, I haven't tested this yet, should be able to scale horizontally. And I had seen an issue in looking at QuestDB when I was looking at to evaluate it. They haven't actually implemented horizontal replication, multi-server replication yet. But it is an interesting one, and it looks like a very performant time series database. It's not clear yet whether that would be useful for other sorts of metrics as well. So I'll leave that for the time being. Here's another article. Now this is looking at various time series workloads. One thing that comes out of this that we need to do some more research around with ClickHouse in particular is when you're doing light queries, simple queries, ClickHouse actually comes out as being a lot less performant than a lot of other solutions, right? That's creating small amounts of data. You can see it's one of the lowest containers in there. But actually, when you then switch to very, very heavy queries, because of the nature of the database, it then starts to perform much, much better. So we need to get an idea of what sort of access patterns we're going to get with this from users building dashboards and visualizing the data. And if they are of this sort of nature, then it would be quite useful. And from my instinct, I think it's going to be the case that we're going to have large volumes of writes, which ClickHouse is very good for, and can ingest a lot of data, has very high throughput, and a less volume of complex reads where there's lots of selection over lots of the columns, merging tags together and things like that. So my hope at the moment is that this would be a good fit. Also, another blog that's interesting is Uber's logging blog entry here, where they talk about migrating from Elasticsearch to ClickHouse as a solution for their logs. I think you can see the sort of architecture diagram here, which is very similar to the sort of architecture we might be looking at for the APM solution, where you have Kafka acting as a set of brokers there to handle back pressure and perform messaging, passing those logs, storing them in ClickHouse, and having abilities to view on top of that. And they go into a lot of details here and talk about the schema they're using and some of the optimizations that they then put in place to be able to provide that data. And at the scale of Uber, that's a very good sign that they're able to use that for that method. And it means, if we can just use ClickHouse for all these different types of observability data in one place, it means from an infrastructure point of view, much less of a headache to have loads of different databases. So what I want to do now is just show you a quick example of actually running Datadog. So very quick. There's a Datadog agent in a Docker Compose file that I'm setting up here. And I'm using mock servers here, which is another project to essentially mock out HTTP requests, captures them and allows you to put in your own responses and things like that. It's good for just being able to analyze, sort of trace the HTTP requests, because as we'll see, the Datadog agent uses a bunch of endpoints that are documented, but some that aren't as well, and we need to look at what it's doing there. So you can see we're setting that up, setting up various URL overrides here, which is a bit awkward. You can see we've got this main Datadog URL, but we also have to override it for different areas that we haven't turned on. But otherwise, the default is just to go to Datadog HQ if you don't override these, which is a little bit frustrating, but it's not a big deal. You can set these up in config. You can set them up as command line args and environment variables. We pass it the Docker socket, the Unix socket, so that we can read Docker state information. It automatically detects that and reads it. And the host proc file system, which is the sort of standard Linux way of interrogating counters for performance for the actual hardware, and the C group information as well, which is related to the way containers run and organize themselves. So if we just stand that up, see those setting up there, and we should see logs from the agent starting to spread out. And if we jump into the mock server dashboard, we start to see requests coming in. So we can see we've got an initial validation request there to validate against our API key. All we're doing with all these responses is just returning a 200 with a body of OK, and it seems to just not care. In fact, initially it was all 404s, and it's still just carried on. So it doesn't seem to mind much what you send back. It just keeps spamming metrics at the endpoint. For these intake endpoints that I haven't had a chance to break down yet that are not documented. So there's lots of stuff documented for the Datadog APIs that you can see here, but that's not documented. And these check run ones, I'm not sure what they're doing here. The main thing we're interested in at the moment is the series posts here. So you see I think it's set to every 10 to 15 seconds by default to send this. And it's sort of a batch request. So everything's building up in memory, and then it does a flush out to the series endpoint. Just another check run there. Let's wait for another one. We should be getting one any second now. Fine, let's have a look at this one. So we'll get pop that one open. You can see inside here, this is your series endpoint. And you've got, for example, lots of system metrics coming in here. So a good one might be to have a look at disk metrics. So I'm going to read. See if we actually get some numbers. There we go. So this is obviously percentage metrics here. So you've got a metric name there, which is sort of namespace, system.disk, write time, I'm guessing percentage. These tuples it sends over, you've got a Unix timestamp and a value here, in which case would be the percentage. You've got some tags, tag formatted here, device name. This is the name of one of the disks on my machine. And you're saying it's a particular gauge metric type. And for this particular device, the interval is not relevant here because it's a gauge. That would be if you've got like a calculated rate or something like that. And the source of data. So you get these sort of metrics coming in from the system as expected. I haven't got to the point of being able to visualize those, unfortunately. I was hoping to be able to get that done this week. That's one of the first things I'll be looking at next week, is getting a basic backend with Grafana. It might not be ClickHouse because it might be a bit complicated to set that up initially. It might be a simpler time series database, and then we can just get ClickHouse set up straight away. Get something like Grafana set up straight away on that. So anyway, there we go. I'll leave it there. Thank you.